We're going to need a case for this, so let's design one really quickly. My name's Andy, I am the Code Rebel, and this is the Godzilla Project early video. Let's call it episode 3. I guess the bill of materials was 2 and the intro was 1. So we're going to design the case. We want a case like this, like a guitar pedal case. This is one that doesn't make it on my pedal board because it's not because TC pedals aren't great. They're fantastic. They're fantastic for the price. They're fantastic regardless of the price. But I just don't like analog delay, and I've got a digital on, and this is why this isn't in. I've got another small example of a case. I don't know whether I'll do a tiny one. This is the Banging Hangover from Landlord Effects. The reverb pedal, it's all right up until the point you put too much effects into it and it gets confused, and that's why this isn't on, because it got replaced with the TC Sky Surfer, which is a fantastic reverb. But this isn't a pedal review channel. All we're wanting to do is to take the case design here. You can buy an off-the-shelf case and drill it out. What I'm going to do, because I am who I am and I'm tight, I'm going to 3D print one, and I'm going to design one perfectly to fit all the components we need. And I like this size big pedal rather than these little mini pedals. I'm going to do both because we can fit the electronics in both, I think. But first I'm going to start with this one, and I'm just going to quickly go through. And this is how to do it for free in Tinkercad. I realise it's probably an amateur tool, but I can get away with it and I can do what I want, and it's good enough for me to get away with. I haven't got the time to learn a better CAD tool. I'm aware there's much more advanced, better ones out there. I don't care because this just does what I need. So let's switch over the camera now to Tinkercad. This is free. Sign up to it with Google and you can get away with as much as you want. So all I'm going to do first off, I've got the design tone, the good old measuring calipers that have run out of batteries. So what I need to know straight off is how big this is. And this is, ooh, it's bigger than my calipers just. It's 130 millimeters long. We're not going to go that big because I want to make it, we don't need all the space inside. We're not pushed. And I want it to 3D print a bit faster. So it's 130 by 75 millimeters. I'm not telling you what that is in freedom units. If you work in inches, figure it out for yourself. The rest of us work in millimeters because it's easier, better type of measurement. So get used to it. And it is 37 millimeters high. So right off on Tinkercad, I'm not going to make it that big. I'm going to make it smaller than that, but not as small as this. But I will do a mini case. I might decide I like them better and go with that. But we'll just take the square for starters. We're going to make it 30 millimeters high, so not 37. It'll be 30. You don't need all the space. It's fine. 45 by 90. That looks like a reasonable dimension to me. And what I like to do to round the corners off, because why I tend to round corners, you'll see in everything I do, where it lies flat on the print bed, I like to round the corners because you get less failed print, because it doesn't seem, when you have square corners, it seems to be like a stress point as you print in and a problem area. And if you're going to get a problem arise, I personally found it tends to come on square corners, like a stress point in engineering. I don't know whether that's just in my head, but that is personally what I've found from things. So we'll merge those two together, and we've got the cutout for the corner there. Take that up so it's 30 millimeter high, and we make a hole out of it. We're going to copy and paste, so we've got two of them, and we'll turn that one around to meet that. Oh, I've double clicked on. My mouse is breaking a bit, and this is why. Oh no, we're fine there. Oh, it's done it again. Like I say, there are better tools out there, but this one's free, and I get away with it, and it does what I need. So we'll copy that there, move that there, and they are both lined up where we need them. So we're going to copy them, paste them, and turn them around that way. And we'll move them up here. There we go. That is all four corners aligned. So we'll Control and A to select all. It's the usual shortcut keys, and we'll hit merge. And there we have our case design. You can still change the height of it if you need to, but there it is with the rounded corners. It's 45 millimeters wide, which I actually thinking on now, that's a bit of a pain in the ass for finding the center line of it, but I'm sure we'll cope fine. So yeah, let's crack on. The first thing I kind of want to do, obviously it needs to be hollow. So the best way to do that, I want the 3 millimeter wall thickness on it, just because I found that works well enough. So we want 27 millimeters high, and that is 45 by 90. So it's twice as long as it is there. So we take 6 millimeters for both ends off the 90, and that gives us 84 millimeters. The width is going to have to be 45 minus 6, that's 39. 39? Yeah, 39 millimeters. What I should have done with that, in fact, I can do it with this. I can unbind that. There we go. We'll select the four corners, copy them, paste them. Doing it again. So that one, that one, that one, that one. So, what is it doing to me today? It'll be because my mouse button, for some reason, is playing up. Maybe I need a new mouse. So we'll click and drag them over there. Worry about them later. And we're going to just select all these, actually. Merge them back together. We'll select these four. This mouse button is going to give me hell through this video. I can feel it coming. But this is what I do. I don't script stuff, and it's all real and live, and this is as it happens properly. So there we go. These two we then need to move to the left a bit. You can use your keys rather than dragging with the mouse. And if your mouse is dodgy like mine, it's probably going to be less hassle for you. That's good. So then we drag these two up there, because we're going to have to trim the corners off this to make it fit inside that. So all we're going to do now, take them, and we're going to union group that. We're going to turn it into a hole, lift it up to 3 millimeter thickness, and we now need, what is it doing? There we go. We now need to move this right into the center of this one. So we might need to change the scale on it. Oh, will we? That looks well lined up. And we can check from underneath. You can count the squares there with 3 off that side, 3 off there. So by association, because it was 6 millimeters all the way, we should be 3 off there and 3 off the bottom as well. Yep, we are. Well done. I can add up. We're going to select all again and union them, and that should give us the hollowed out box, the enclosure. Maybe at some point we'll do a back for this. I will. I'll do one. I'll do one later. But sometimes it's nice to leave the back off so you can get in and mess around. So we need to know now our momentary switch there that's going in. We need the size of that. So I'll measure that. And it's about 11 point something millimeter. So let's call it 12, which is great, isn't it, for taking something that's 45. This is why I like even numbers, because they're much quicker and easier to work out with. Somehow, I guess if you're better at maths than me, it's not too much of a problem. But now we need the halfway point of 45, which, I know it's 22.5, but we're going to have to set our grid there to 0.5 millimeter steps, and we're going to place that so we're 2.5 millimeters in on that line there. So either side will be 2.5. That's our center line. And we can go back to a 1 millimeter snap to grid now. And what we want to do is just place that kind of evenly in the bottom. So we'll be, maybe we should have done it the other way. I didn't. I did it that way. So we'll move that back up, and with 13 millimeters off the bottom, and that should be 17.5 off the sides. That gives us plenty of room and space for everything, and we'll get that threaded part of the insert through. We've got more than 3 millimeters to play with, so we don't need to kind of thin any parts of the case out. So there's our switch in. That's one part done. I have, as well, as I forgot to mention in the bill of materials video, because this is completely unplanned. If you're me, these aren't all the ones, but these are the ones that are considered to be used for this. I've got a small black with silver. I've got a medium large gold, and I've got a large black one. So I don't know which one I'm going to select. I'm leaning towards these two because this one's a bit little, and when we've got one pot on it with one knob, it's nice to just have one larger one to make it cool. So I'm going to go with them, and I might center it, I might not. Let's find out when we come to draw that on now. And we've got the volume pot here, so we need to take a measurement, and it's got that little tab on the side, so I will hollow out for that in a bit, but I'm not going to do it on this video. It's fart arsing about, and you can figure that out for yourself if you want to do these, but I will release the STL anyway, so you can do it yourself. So measure that, and these are only about 6 mil, so I'm going to do 7. We'll call it 7 on the measurement. So how do we want it to look? I kind of think we'll bang it right in the middle there at that point. So we need 7. Yep. It's a bit awkward working from this angle. I'm sure I'll figure it out. 6, 7, and we'll knock that down to 7 in both directions. So we then want to put the grid back to 0.5 millimeter to line that up with our selected cross in the middle there. And you can see the center line, it's quite handy, just pop in there. So we're that much down and centered. Yeah, we'll do that. I think that's going to look all right. So select all, merge them. And that's our 2 holes drilled in that format of case. And it looks kind of cool. I want the jack inputs through the top there. So let's go back to the... I probably shouldn't have done that before I measured them. We might find out they're an awkward size. And again, we just measure that, and about just over 8mm. So we're going to call it 9, because the last thing you want to do when you're doing this, I know it's nice to have real tight tolerances and get everything absolutely perfect, but the last thing you want is to print it out and then find actually parts interfere, or they don't quite fit in the holes, and wouldn't be the first time I've done that. Just saying, it really wouldn't be the first time. So we leave plenty of space between these. Maybe that looks good, actually. I'm happy with that. I think I'm happy with that spacing. So that's not evenly spaced, is it? What have I done? I've gone 3mm over there, 3 over there, and that's 8 in the middle. 8 in the middle of these should be plenty, because you can twist them around as you put them in to line the tabs and the pins up on the back. But we'll just double check. That is about 5mm the sides on them. So maybe at that, with the 8, yeah, we would get a little bit of interference, and that's why it's always worth checking. I'm going to space them a little bit further like that. Where's that coming down? That is half. It's not. Oh, the center will be half. Yeah. That should do it, because we've got 6mm, so we should have a 2mm gap in the middle. No problem. Where was my height again? Where was my height? That was slightly odd value as well, wasn't it? We've got them. They're going all the way through. Will that go in there? They're a bit close to the edge, actually, aren't they? Right. Well, we'll get them. No, you know what I'm going to do, actually. Just to make sure they're spaced in a little bit from the sides. We're going to put them on that 0.5mm setting. We know they're the right. I'm going to find out now, that I should have left it that. So how high are they? 9mm, and that's 30mm high. So knowing that the case is 3mm and we want at least a 5mm gap, they need to be at least 8mm high. Let's put them at 10. 10. Yeah. So they're not quite up to the edge. We might put something and a lip in there to close the case. So it gives us a little bit more room where we need to, but there's plenty of clearance around the top there. We might have a problem on the inside, however. Will we? I think I'm going to live dangerously. I'll 3D print one of these, and I'll make sure, and I'll fit the parts anyway before. So you'll get the nice polished revised version after I've spent 12 hours watching this print and then realize I've done something wrong. So yeah, I think that's all right for the case. We'll select all, merge that, and I'm only just going to do a quick view from underneath there. That's all we need for our mix volume pot and our switch that's going in the bottom. That does look huge, but I guess it is compared to the other holes. So yeah, nice big hole on the end. That'll print that way up fine, and it will just put a little bit of support in there to keep everything up where it should be, basically. Yeah, that is our 3D printable electronics case. And download it now. I'll get on with printing. This is the Godzilla Project series, where I'm just messing about with stuff. That's how you design a case with Tinkercad. Dead easy, no fuss. And what? We're all done within 20 minutes, and that's me wittering on, doing stuff and figuring it all out as I've done it. But yeah, like, subscribe, follow this series, build along if you want. Or maybe you want to wait to watch me make a mess of stuff and then figure it out at the end and what you do want to do when we've got the correct answer and a decent result. Either way, give me a like, give me a boost, because that would be fantastic. Subscribe if you want to follow the project series along. Buy me a coffee because I'm doing amazing work for you. And I will see you on the next episode. Thanks for watching.